directions said to find AC. So armed with the knowledge that BD is a median means a segment that goes through a vertex and goes through the midpoint of a side. So it has to go through a vertex and it has to go through a midpoint. So you should have started this problem by setting x plus 3 equal to 2x minus 17. The x minus 7 was just there to trick you. You don't add those up to equal 180, nothing crazy like that. What'd y'all get for x? Because that was not your final stop, not your final destination. X was 20, right? And then you need to plug it back in. Once you know, like, let's plug it into the easy one. This is 23. Once you know the easy one, you can just double it because it's a median. It's in the middle. So both sides are congruent. So AC was 46. Okay, so we know, we have the knowledge that AD is an altitude. An altitude has one job and only one job. It needs to originate at the, it doesn't start anywhere, but it needs to go through the vertex, and it needs to be perpendicular to the line containing the opposite side. So when you see the word altitude, you add a 90-degree angle marking. What do you think some students do that get this wrong? They set 2x equal to 3x minus 4. They assume that D is a midpoint, where there's no information given to us that that was a midpoint. So all you do on this problem is set the angle that is 90 equal to 90, since that's what it equals. So add 10 and divide by 4 to get 25. Only 11 of us got this one right, guys. BD is an angle bisector. An angle bisector's role is to divide an angle into two congruent angles. We know that the given angle is x plus 6 and angle ABC, so the entire angle is 4x minus 6. So we know we can either half the whole or double the half. Those are our two options. So we could say, oh, these are congruent. So this one's x plus 6 as well. And we can just add them together. 2x plus 12 equals 4x minus 6. Let's see, 18 equals 2x divided by 2. X is 9, and it was asking for angle ABC. So we need to plug it back in. 4 times 9 minus 6, okay? All right, so we know that the angle ABC is 80, this whole angle, and ACB is 40. So we're just trying to find the measure of angle X. How'd y'all start this one? What'd you find first? So we know that by triangle sum theorem, the angles of a triangle add up to 180. So we would have, let's see, 60 left for right here. So angle A is 60 degrees. Where do we go from there? I mean, this is not a triangle. What do we do next? Yeah. So when a figure has so many lines going on, you need to look for triangles. You need to be really good at finding triangles inside triangles. So I spy a right triangle right here, right? So that could help us find that missing angle. Let's see, we have 60 and 90, so 180 minus the sum of 60 and 90 would be 30, right? And then I spot another triangle right here, this purple one. And if that angle is 30, then this angle is back to 60 again, right there. And then we simply have a linear pair. So multiple ways to get at that answer. If you knew that the angles of a quadrilateral added up to 360, you could have used that right here, but that was not really taught in our unit, so you were not expected to know that. One student said they did this and formed a triangle that way, but you have to be really careful because you don't necessarily know those other two angles. But either way, answer is 120 degrees. Good job, guys. I almost don't even need to go over this one. All right, so we have an isosceles triangle here because we see two congruent angles. So we know this is 50 degrees. This one's 90, so if I do 90 minus 50, I have, 40 degrees here. And then I have a right triangle. So we're going to end up back where we started because this is a right triangle. And if I add up 90 plus 40 and subtract it from 180, I'm going to be back to 50 again. So the answer to that one was 50. You could have also looked at it as parallel lines cut by a transversal right here. And you could have done alternate interior angles. I know these are parallel because with this transversal, it's perpendicular to both lines. And so I know that those are parallel. So multiple ways to get the same answer. Yay! Most of us got that one right. This one, like I said, should be quick and easy. So we do 180 minus 80. We get 100, and we divide that evenly, 50-50. Then we use the linear pair theorem, and we have 130 right there. You could have also used the exterior angle theorem that says add those two up, and you'll get this angle right here. So whether you add or whether you subtract, that exterior angle was 130 degrees. 5 of you still got this one wrong, so let's see what happened. So we're going to work in this triangle right here first. So we're going to do 180 minus 130, which gives us 50, and we're going to divide it by 2. Now, you can trust angle markings. Trusting angle markings doesn't mean you're assuming something. It means it was given to you. It's given to you that all 4 of those angles are congruent. So 25, 25, 25, 25. They're all 25. So now when we look at this triangle right here, you could always redraw it to the side, especially on a test when you want to get each and every problem correct. When you know that those 2 angles are 50, then the only thing that that one could be is 80. So triangle sum theorem and isosceles triangle there. All right, so how do you find what the length of the third side could be given 2 sides? So this is really important to know for tomorrow. Okay, sorry. So you add them up, 6 plus 13, and you get 19. That's your max. You subtract them, 13 minus 6, and you get 7, and that's your min. So your answer needs to be greater than 7 and less than 19. All right, so now our triangle has sides 20 and 30. We add them together, and so the maximum our third side could be is 50, and the minimum our third side could be is 10. So that's a pretty big range. The sides could be anywhere greater than 10 and less than 50. All right, most of us got this one right. This one was kind of a different problem. We haven't had one like this. Cassie bikes 5 miles from her house to Brad's house. Then she bikes 8 miles from Brad's to Lindsay's, and then 12 from Lindsay's back to her house. Which angle is the greatest? So, of course, we find the greatest side, and the largest angle would be across from the longest side. So the answer was angle B. All right, so let's begin by finding x. So we know that a mid-segment is half the length of the base. Not the base, but the third side. So we've got 10x plus 14 equals 11x plus 10. So we subtract 10x from both sides, and we get just plain x. We subtract 10 from both sides, and we get 4. Did we get that? Everyone got x is 4? X is 4? Yes. So now let's plug x in. So when we plug it in to RT, we get, let's see, 3 times 4 is 12. We know this is 12. So RT is 24. Now we take the 4 and we plug it in down here. 11 times 4 is 44, plus 10 is 54, right? So we know 2 sides of the triangle are 24 and 54. What are the possible lengths of the third side? So I tied a lot of different things into one problem. So what do? You add them together and you subtract them. When you subtract them, you get 30. That's your min. When you add them together, you get 78. So x is greater than 30 and less than 78. All right, so we know that UA is 30. Let's stop right there. The side parallel is going to be half of the length. So this one's 15. PE is 6. We know that the whole side PA is 12, so divide it by 2. So the parallel side is 6 as well. And UP is 15. 15 divided by 2, 7.5. So you just add those up, 6 plus 15 plus 7.5.